Okay, it looks like it's time to start the session. I can't really tell what how many people we have in the room, but looks like we have quorum at least online. Welcome to IETF 119 Brisbane. Welcome to those who are physically there and those who are virtually there. I'm Lou Berger. We actually have a full contingent of working group support at this meeting. We have also Janos Farkas online, Yves Schuler online, and in the room are in-room delegates who are helping us out. Thank you to Balazs Vargas and Don Fedek. I've already put in chat a link to our joint minute taking. Please jump there and help us. I'll, of course, mention that again a few times while I do the intro session. This is a IETF meeting, which means our processes and rules apply. Everything you do here becomes part of our permanent record. You should be familiar with our note well. If you are not, please take a look. If you go to the link in chat, that'll take you to the minute taking, which will also take you back to the working group page, and you can find these slides and also where to get our note well. In addition to governing our rules of disclosure, we also have rules that talk about how we treat each other. And it's very important to, even when we're having some good heated discussion, to remember to treat each other professionally and with respect and courtesy always. We ask that everyone sign in. If you if you're in the room and you haven't scanned in, please scan in. This is how we're going to manage the queue. And it also gives us a good idea of the count of people, the count of participants. If you're online, well, you figured out how to get here and probably don't need more instructions. We are going to use the integrated queue control. So again, please scan in, and we will be managing the queue remotely. If for some reason there is a problem with the network, our in-room delegates will take over and just run the meeting as well as they can. They are both quite capable. We have a published agenda. They will run through, and those of us who were remote will have to, unfortunately, catch up with what happened. All material is posted, and we do also have the chat session. Here again is the link that I put into chat. Please help join us for joint minute taking or note taking. You don't have to capture everything that's said by the speakers, just the discussion. We have two sessions. Obviously, this is our first session. We have a session later in the week as well. The second session is going to have our queuing discussion, our enhanced data plane discussion. And that is, I know, of interest to many. In the first session, we are going to focus on, we're going to start out focusing on status of our working group documents, then move on to some raw discussions, the radio air wireless, and then a miscellaneous, a couple of miscellaneous presentations because it fit better with the time. As for the working group authors, it's very important to not only highlight the changes, but also what is necessary to complete the documents. We really want to focus on what are open issues and have discussion and highlight those open issues in the working group documents. For non-working group documents, please tell us what you're doing that's new and what's not already covered. And also, what are you asking from the working group? The formatting of this slide did not translate well from the PowerPoint, so I apologize for that. On the PowerPoint, it was all nicely lined up, and you could tell the status what tied to the document. But we have one new RFC, and that is our purpose here, is to produce documents. So that's great to see. Thank you all who contributed to that. We have a fair number of documents post last call and submitted to the IESG. The first set of 4 are in the RFC editor queue. That means the hard work has been done, and now we just have to go through the editing process. And it's very good to see, again, the hard work the group has put in, yielding demonstrable results. We have a couple of other documents that are with the AD. I see John there. I don't know if he wants to say anything, but unless he gets up, I'm going to keep going. We have, right, we're going to keep going. We have one document that is post last call that came over from RAW. That is, you're going to hear, is a document that still requires, some additional work. We also have a recent adoption that we'll be talking about briefly today. Not on the agenda is the controller plane framework and the RAW framework. Both of them, we've been struggling to get momentum on. And we're hoping that we can continue to get contributions in these areas so that we can complete this work. If you are interested in contributing, please contact those who are listed on the document. If for some reason you're not getting responses, please feel free to take it to the list or bring it to the attention of the chairs, the honors for myself.
I can talk to this one if
yes.
you want.
Yes, please.
Since the last IETF 118, we have received 2 liaison statements. The first one in the slide and in time was, okay, I think Shasang wants to say something about maybe to the previous slide. If I see right.
Why don't you finish the liaison slide and I'll flip back.
Okay, so first one is from IEEE 802.1 working group. It was for information about 2 projects that are considered most relevant to the work in the IETF DETNET working group. And luckily we had an interim meeting last year in December where the editor of both of the projects, Norm Finn, gave a presentation. So there are all the links and recordings. You can check that one. It does not require a response. And the second liaison statement has been received from IETF Study Group 13 on work items related to deterministic networking communications. Maybe the link in the slide is not correct, but I gave it to the chat window as well. And it has multiple points it makes. First, they have consented one recommendation to deterministic communication services, and they have started to work on a couple of other draft recommendations, and one of them has the title I have, sorry, first of all, the published one is attached, so you can take a look at the liaison statement page. And as for the ongoing ones, I copied the one of them to the chat window, which is requirements and framework for stateless file queuing in large-scale networks. And as I understand, this is one of the queuing methods being proposed to the DETNET working group. And it looks like this IETF Study Group 13 Question 6 group goes ahead standardizing it, whatever the DETNET discussions are. This was for information as well. My personal understanding is that no response is needed. That's it. Thank you.
Shusang, please go ahead.
Shusang from Huawei. Actually, as the co-author or the author of the controller plan framework, actually we want to seek the comments from working group chairs. Because there are some comments from working group about ending the role part previous rule part consideration into the existing document, and we have already, we are very welcome Carlos as new co-author, and there are some contributions about the coordination between different controllers. So we think the document is quite static, and there is no significant update these days. So we are seeking for working group last call if the working group think it is ready.
Okay, thank you. I think it would be good if you can summarize that on the list, and then we can take the discussion from there.
Okay, I will send it to the mailing list.
Okay,
And also there is another document, also working group document. It is DETNET topology Young model. And it is kind of part of the DETNET Young model beforehand, and then it is independent now. From the requirement from the requirement of 3GPP side, we have active the document again. So we also would like to, we have give presentations beforehand. We also would like to see whether working group think it is, meaningful enough to go ahead, or it, if working group think it is inside scope of our our scope now, the others will update the document and give presentations, perhaps. Do you remember? Because it is.
yeah, I mean, we definitely considered it in scope. So hearing updates on and progress is really important if we want to complete the document.
Okay, thank you.
Okay. I'm actually going to jump ahead because we have 2 slides that we normally do about IPR process. We're familiar with that, and we're familiar with progressing work online. One thing that we want to do a little differently, and this really sort of highlights the comments that were just at the mic, is we want to make sure that we're getting status at every meeting on every working group document. So we're going to do, we're making a bit of a process change where we're asking that status be provided in the form of a report in the IETF meeting, and with a little notice so people can come prepared to have a discussion on it, or for a report to be sent to the list at the same time as the internet cutoff draft. So again, we can facilitate discussion, more substantive discussion on, comments like Shusang just gave us. Had we had that a couple of weeks ago, we actually, the group could have been ready to have a good discussion about those things. So we're just going to make this change going forward, and want the working group to be aware, and of course the authors, it's very important that they be aware. Torlis, if you want to come to the queue, I'm going to change decks while we're doing that, and I think Janos is going to speak next. So please go ahead, Torlis.
Yeah, just as one of those procrastinators and kind of having my time slice of writing drafts up to the deadline and then doing presentation, all the other stuff. If the more you can move out when the presentation is ready, I think the more you help the contributors with that. So having that on the same time as the deadline for the drafts would be sub-ideal. So if it can be a week later, that's a week before.
It's a status. We don't need the slide decks. We just need the status, or a request to present. So if you want to be a procrastinator, the thing to do is to on that cutoff time, put in a request to present, and then you have an extra 2 weeks to get your slides together and come to the working group and have a good discussion.
So right. So it's if you don't present, but maybe even just did I kept it alive, but like, yeah, okay, thank you.
Thank you. Okay, Janos.
Okay, thank you. This presentation is a summary on the updates happened to the raw architecture draft. I'm speaking as an individual contributor who actually contributed most of these updates. And this is just a summary of the updates. There was a new figure added, and there were some corresponding and related terminology change and cleanup, and a couple of fixed nits updated. There have been emails postponed on practically speaking every step and change. These are linked. This actually originates from a review of the previous draft version 16 before the previous IETF, and most of these suggestions have been made during this review, and including this new figure. So in that email you can find this figure, which is now part of as a proposal, as a contribution, part of the current version 17 draft up for discussion. The basic idea behind this figure is how to illustrate the essence of DETNET of row. I mean, adding row to the DETNET architecture. And this new figure, which is figure 3 in the current draft, is based on the RFC DETNET architecture, figure 4, which gives the layering figure for DETNET in that RFC. And we have introduced for DETNET the forwarding sublayer and the DETNET sublayer. And actually what we have now with the focus on wireless in row is the wireless or radio layers underneath, under the DETNET layer. And I think a key component of row is the row API that gives an interface between the classic DETNET layers and the wireless layer, and opens up the possibilities in support of the wireless aspects that have been presented in the specialties presented in the row architecture draft. And a key aspect of what we have been doing in the row work is reliability, addressing reliability, improving reliability. So this figure illustrates the location of the different reliability features. For example, a couple of examples are given. The radio layer has the HARC, and we have defined for DETNET the pre-op functionalities in the DETNET service sublayer. One of the proposals in the row is the faster reaction to the failures or updates, changes in the wireless condition, and therefore the PLR has been introduced. And the way I see it is closer located to the wireless layer in order to be able to react. So it's part of the forwarding sublayer, and it has inputs from radio conditions that can come from the radio API or can get input from OEM. Moving on, the rest are related to the figure actually. Why is it not changing slide? Let me try it. Okay, so the further updates are in the text and somewhat related to the figure. With the help of Don, we have updated the definition of ARC, and the rest are a major update is that actually giving the focus of the row API, and as it is shown in the figure, the formerly used Parao, which is a sort of a combination of HARC and the pre-op functions. These are located very far from each other, so it's not that meaningful, or actually I used to say the layer violation, because it's not even connected layers. So therefore there was an update to revise the use and actually remove the term Parao and focus on the row API, give more explanation on it. There were already parts that were part of the previous drafts, but make it more explicit. For example, there's new text in the introduction section capturing the essence of the API, which actually makes cross-layer optimization possible, for example, for the reliability features. So technically, we still have the same capabilities if somebody wants to have optimization among the various reliability features. That's there. The capability is there. It's just written in a little bit different way, focusing on the row API. And as I see next steps, actually, with the introduction of this new figure, there may be some parts that are not fully consistent in the draft. I would like to go through and double check. Honestly, I did not have the time for that before the update, and I actually thought to have it a little bit step by step, bringing to the working group. If the working group is happy and agrees with this approach, this direction, then I'm happy to do this cross check and potentially propose further changes. And I think we have been discussing it before that the architecture draft still goes on through these updates, and at some point when the group or we think it's stable again, there would be another working group last call. That's the update in brief. Any comments? Yes, Lou?
Yeah, so I have a comment. Feel free to take it as a chair comment or a contributor comment. But in looking at the document and getting ready for it, for the next last call, I do see that there's other inconsistencies in the document. Notably in the definitions, there's a lot of repeat of text from outside of the document, and some of the repetition is not quite the same as what is in the original source. So I think, unfortunately, that's going to take a bit of cleanup. And maybe we can do it by reducing and just say for the definition, go look at the source as opposed to paraphrasing. But we're going to have to work through that as part of this document cleanup. So I agree with what you said here about potential inconsistencies, but it's the introduced by these updates is the part that I'm saying is too limited.
Yeah, I agree that the document would benefit from such a cleanup as well. Yeah. Okay, I pass the control to you, Don.
Carlos is next up.
Sorry. This is which number is this? Three.
Number 3, Carlos.
Can you hear me well, by the way? Well.
Yep.
Okay,
Yeah.
perfect. Okay, thank you, guys. This is Carlos Bernardos presenting this document on behalf of my co-authors. So this is the requirements for reliable wireless and industrial services. Next slide, please. Or can I have the control? Okay, perfect. So just a reminder, because this document comes from the RAW working group. So the main goal of this document is to provide an overview of the requirements of DETNET wireless in the context of industrial applications and services. This kind of complements a bit both RFC 9450, that is the use cases of RAW, and also the original use cases document in DETNET. I don't remember the number, sorry about that. So the idea is to go a bit into more details for this specific application area and identify a set of requirements. So what we have currently in the document is basically we document both existing applications using Wi-Fi mainly, and the requirements as found in the state-of-the-art or related work. So with kind of bit of details in terms of specific requirements, latency, reliability, this type of things. And also analyze potential future services and then identify requirements in the context of wireless DETNET. So that's a bit the main aim and scope of this document. This is the current table of content. Just by the way, the content of this document is exactly the same as it was when it was named Draft IETF RAW. Now it's Draft IETF DETNET RAW. As we understood this, was the request or the instructions from the chair to basically copy, paste, and then resume the working as DETNET. So this is the current structure. Basically, there are two main sections. Section 4 on the wireless industrial services today. So those that are based on an AO2.11 with no additional kind of technologies on top. And then the additional kind of more future reliable wireless applications and services, where we have 3 currently in the document, and where we try to go a bit more into details and additional requirements that are relevant for DETNET RAW. And then a summary of what we have done and what we would like to do in the future. As I implicitly said, we resubmitted the document Strata IETF DETNET RAW in January, as agreed in the last IETF meeting. Eva and myself joined the co-authors team. And then as next steps, we would like to get feedback from the working group in terms of, is the content okay? Should we add any additional wireless application or service? So we update the structure, and there is a comment related to that. Do we have anything missing? As an author here, I think that we probably need to change a bit the structure to make section 4 and 5 more consistent, because 4 is more like, okay, this is what is there already, and document and identify or list more than identify requirements. And 5 is more like, okay, those are more future things, and those are the potential requirements. And I think we need to be a bit more consistent, because the structure following 4 and 5 are not exactly the same. But in any case, what we actually need to progress is feedback from the working group, because this is a working group document, so it's not our document anymore. So we need to get this type of feedback to work in a new revision and potentially get to working group last call soon. So any comments, any feedback?
Yes, I have a comment, and you also touched upon it during your verbal report in the previous slide, that actually I think, and I may be wrong, but I think wireless requirements are technology independent. So they are requirements in case there is a wireless domain segment hop or whatsoever. But as you said, this also, and that's what I found in the draft, this is Wi-Fi focused. And I don't fully understand, why do we have to pick on any of the wireless technologies when we craft requirements? So these are requirements that can be addressed by either raw technologies. So my suggestion would be to remove technologies from the draft and focus on requirements, really.
I agree with that comment. I think that the way it was done, because I joined the team just recently, is that the first part, section 4, is taking application services that are running today and basically identify the requirements that are fulfilled with mainly Wi-Fi. But I agree that we can just document that as those are the requirements, and we can mention that for some of them, Wi-Fi is mostly doing the job, while for the section 5 application services, those are like more strict, and this is where DETNET RAW or that wireless DETNET will get into the picture. But yeah, I agree. It should be technology agnostic. Yeah, so we can do that review as part of the updates in the next revision. Thanks. Okay, so please try to send your feedback on the mailing list, and I'll try to ask again for feedback on the mailing list as well. Thanks.
Let's move on to the next presentation. Yes.
Hi, my name is Balázs Varga, and in this presentation I will speak about the result of the analysis of the latency characteristics of mobile transmission. So this analysis we have done in a European Union project, Deterministic Networking, and we are sharing these results here. And I am speaking on behalf of the co-authors, Frank Dürr from Stuttgart University, Sami Mostafavi from KTH, the Royal Institute of Technology, my colleague Joachim Sachs, and I am the fourth author of this draft. Next slide, please. So in this draft, what we are focusing on is that if you would like to provide deterministic communication and you have a wireless link, a mobile communication link in that system, that mobile system will add special characteristics, and it will have special challenges regarding the DETNET flows, what you would like to serve there. So this document really providing a detailed analysis why are these latency characteristics different and how these latency characteristics are coming from the radio protocols, from the components of the mobile system. Recently, there were many discussions on what functionalities we would like to define in DETNET workgroup in order to provide that bounded latency. And we intend to add this analysis as an input to those discussions, because we believe if we would like to build up an end-to-end DETNET system where you are mixing wired and wireless technologies, then you need wireless-friendly latency functionalities in that. Because that is the way how to ensure the flexibility and the bounded latency and the DETNET specific requirements. And we also think that this analysis will also help to develop new future approaches, which are, for example, based on using data-driven latency characterization. So that can be also a new direction to those discussions. When we look to the mobile systems, 3GPP is defining in various releases how these systems are working on. And they started to focus on reliability, latency, extreme quality of service requirement in release 16. And they have defined a lot of functionalities in the mobile system. And this is what is called URLC, ultra reliable low latency communication toolset. They have created a framework in order to represent the mobile system in these time-sensitive communication environments as a virtual node. And that is the case also for the DETNET. And in release 18, they have defined the DETNET specifics and the requirements and the toolset in the mobile system. Next slide, please. When we look to the mobile system, then there are various components. How this virtual DETNET router is defined, it is binded together with the user plane functionality. And if we compare the wired and wireless virtual nodes, DETNET nodes, there are various differences. So on this slide and also in a section in the draft, we have just listed these significant differences. And we have very much focused in a dedicated section on the latency characteristic. But there are also some other interesting differences, I think, what we should consider when we are designing end-to-end the DETNET network. One is the physical distance of a port. If you have a wired node, then you have practically decimeters between the ports, the ingress and the egress ports. This is not the case if you have a mobile system and you have a virtual DETNET node. Because on that virtual DETNET node, you can have hundreds of meters or even kilometers between the ports that you are using on that virtual router. There is also a difference regarding the number of ports. In a mobile system, on this virtual DETNET router, your number of ports can change over time as various endpoints are moving around in the mobile system and they are changing connectivity to the system. Latency characteristics, we will speak more in detail in the coming slides. And there is also a difference in the dynamicity of the characteristic of a node. In a wired node, you are designing it, you are implementing it, and you are expecting a very thin range of parameters that will be there when you are using that device. The aim is similar in the mobile system, but in case of a mobile network, you have also radio conditions, and those radio conditions can change your characteristic during the lifetime of your connection. So the intent is here, but we wanted to highlight with this draft is really to point to the differences between wired DETNET nodes and wireless DETNET nodes. And we think that this wireless friendly implementation of latency functions that is also essential in order to being able to build end-to-end a mixed environment. We have a dedicated section, and that is the main focus in the draft, where we are doing a latency breakdown practically, how the latency characteristics is built up in a mobile system. One of the most important contributor to that latency characteristics is HARC. This is the hybrid automatic repeat request. So practically with that system, what you would like to achieve is spectral efficiency and robustness, and the cost is latency. So with additional retransmission or partial retransmissions, you can ensure that your communication will be successful. There are also handover scenarios where you have different cells in the radio network, and when one endpoint is moving to a different cell, you have to change the states in the radio network. You have to build up your connectivity somewhat differently, and that takes time. So during the handover, you can expect also some latency impact in the mobile network. The third contributor is the time division duplex structure. So this is a structure which is deciding when you are able to send uplink and downlink traffic in that mobile system. And there are various configuration options. Some of them also are defined by regulatory authorities. So this is also something that will impact when you will be able to send your packet to the other endpoint. And of course, also in high load scenarios, you might see some congestion. You need resource sharing and queuing in the mobile system, and that will also impact your latency characteristic. We have also pointed out in detail the QoS architecture within the mobile network in the draft. And we have also analyzed the latency contribution of the different radio protocols in the radio stack. We have a very short, but we think really meaningful section where real network measurement were also shared in the document. And this packet delay distribution was coming from an open air interface 5G network. And practically what we are showing with those data is which component of the radio access network is contributing most to the delay characteristics. So as you have higher reliability on the latency bounds, of course you will have a bigger packet delay variation impact on the transmission itself. Yeah, and why it is so important? It is important because if you are doing your end-to-end scheduling, you have to consider these characteristics. In legacy and normal scheduling algorithm and designs, you are practically assuming that your packet delay is deterministic between the ingress and the egress points. However, with that modeling, that the whole mobile system is modeled as a virtual DETNET router, the radio link characteristics became an internal forwarding delay component. And that must be considered when you are doing your end-to-end scheduling. However, if you are looking to legacy scheduling design and solutions, you will face issues because these are assuming that you have a deterministic delay, and you do not have a packet delay which is stochastic and heavy-tailed. So this is something that have to be considered when the scheduling algorithms are discussed and designed. So as a summary, next slide, please. The wireless communication that provides flexibility and simplicity. You might have much less hops in your network, for example, if you are using those radio connectivity. And of course, this radio link is stochastic and heavy-tailed from latency characteristics perspective. Some of the shaping mechanisms like the QBV, which is used in TSN network, and this is also can be treated something like as a grandfather of many algorithms we have discussed here in the DETNET work group. They are expecting that you have a very deterministic latency behavior at every hop when you are doing your design. And with that mobile virtual deterministic node, this is not really the case. So we would be happy to have feedbacks and comments on the mailing list or here also in the room regarding this work. And we think that really this discussion on wireless friendly latency algorithms, this is something should be part of the discussion when we think about what latency functionality should be used in order to provide that end-to-end deterministic behavior. Any questions, comments?
Xiaofu?
Hello, this is Xiaofu from ZTE. My question is that I think the transport network between the G node B and the UPF is also a network that can be applied by DETNET. So do you think that this part of the version node should be indicated by DETNET network? Thanks.
So if I understand your question correctly, it is about the RAN network. And yes, that is the most important part from this deterministic characteristic perspective of the mobile system.
Yeah. My question is that do you think this transport network between the GNB and the UPF should also be indicated as DETNET? Because now we just take it as a whole virtual DETNET route.
I think that concept is not bad. So this is something that we can work with, because that will make more easy also the control plane communication with the mobile system. So if you would like to segment the mobile system one by one and adding deterministic capabilities to that, I think that would be a really hard work to do.
Okay, thank you.
Carlos Eckert. Yes, I think the likely setup is like if I would use a normal wired network and I'd be measuring the latency that I get from my DETNET traffic when I have it in there is the same priority as any best effort traffic, right? So you're probably not having, reserved capacity in the network just for the DETNET traffic, but the latency is just your poor DETNET packets or raw packets versus all the other crap, right? At the same priority.
Not really. So what we have also described in the draft is that there are many parameters of the radio network that can be tuned even on a per session basis in order to provide better characteristics for DETNET flows. So that is part of the story, that you can configure much better the radio network. So if you are just using a best effort configuration optimized for mobile broadband, that is not something that you would expect for that traffic. That might be enough for some DETNET traffic depending on your latency bounds. So if you have a control loop running every 100 milliseconds, that is something easy to achieve with the mobile broadband configured radio network as well. But as you are going tighter with your control loop, then you will have more challenges.
Yeah, I think I'd love to understand a characterization of the worst case impact of non-DETNET traffic to the latency, right? So in wired DETNET, the worst case impact is really in the order of a single packet that is still being sent out, while the next packet can be a DETNET packet, right? So that's a very small, very fixed, understood latency. And I guess with all the complexity that you were mentioning, it would be lovely to read some description of what the worst case impact of that other traffic is, right? So that just to distinguish between all the difficulties that you get in latency because it's radio and all, whatever is flying through and all this stuff versus the impact of competing traffic, right? Because the larger the impact of competing traffic is, the larger there would be really the consideration that, well, maybe 5G as it stands is not a good solution if we really want to have hard deadline limits, right? As you said, right, a hard limit may be expensive, but it would be lovely to understand the distinction, right? Wireless versus traffic impact.
Yes, so there is a QoS architecture in the mobile system. This is something that we have on high level described in the draft, but that can be definitely something where we can make as next step discussion in order to highlight that, because with that QoS framework, the QCI, you can also protect your DETNET flows in order not to have impact from other type of traffic.
I mean, I was doing a little bit the designs, what we tentatively wanted to do and never got to get as high as possible reliability with deterministic latency and Wi-Fi, right? So the 802.11 body has done a lot of things to prioritize packets, and you can get more airtime, and so there are a lot of things you can do. We never got into the final formal math on that, but I think it's in a similar way to try to figure out what is within the framework the best and how good it is compared to other wireless solutions, right? Because ultimately it's also Wi-Fi is competing, right? So especially in smaller environments like a town or so, and so would you rather take 5G versus Wi-Fi if you wanted to have latency critical?
Yeah, but that is exactly why URRC functionalities were defined at release 16, and you are building your DETNET and TSN architecture based on those functionalities. Yeah. Okay.
Just a quick reaction to Shafu's question. Maybe the question was about the use of DETNET in the 5G system inside, and that is part of the original DETNET use cases. So for front haul and back haul, you can use DETNET, and in that case, DETNET is a building block of the 5G system. And I think Balázs was talking about, in this case, sort of a DETNET overlay like 5G and the wireline domain, and provide end-to-end DETNET service. So these are two different cases, but can be combined together. Thanks.
Yeah, thank you.
Thank you.
Okay, this is Li Zhang from Huawei. I will introduce a BFD extension for DETNET remote defect indication. Next slide, please. Okay, this page is the background. DETNET provides a reliable packet delivery service for data flow, and it has a strict queues requirements, including bounded end-to-end latency and strict packet loss ratio and bounded out of order packet delivery. And also DETNET OEM requires quick defect deprecation and remote dedicated indication. So, but existing RDI protocols such as BLD are just used to detect and report failures, not specific to DETNET domain defects. Okay, next slide. So let's look at DETNET specific defects for the defect detection method is required, but it is out of scope of this draft. So, and for the RDI method is required, and in spite of latency out of order and losses, and these aspects are not considered in BFD. So there are no explicit DETNET specific defect indicators. Next slide, please. And so we need to define DETNET specific defect indicators to indicate DETNET defect to the remote node, including a ratio of out of order packets and packet latency and the ratio of packet loss. Next slide. And so we extended the BFD control packet. There was a field named diagnostic in the packet, and it was used to notify the remote node that the reason for why the session was failed. So we the 0 to 9 of the diagnostic code is used in existing Alpha 6, and from 10 to 31 are reserved for future use. So next slide, please. So we open the DETNET basic error codes to the diagnostic code. There are packet misorder ratio limited reached, and packet latency limited reached, and packet loss ratio limited reached. Next slide. Yes, we also provide two formats for different forwarding plan. One is IP and MPR, and another is MPRs. They are both consistent with the DETNET IP and MPRs data plane. Next slide. Yeah, okay. The next step is we are going to collecting comments and suggestions to improve our drafts. And next, that's all. Thank you.
Greg?
Yes, Greg Mirsky, Ericsson. A couple notes that I want to make on this work. So yes, I agree. So doesn't seem to be specific for DETNET. You introduce these values and they will show up in all BFD. Again, you suggest to use BFD as a transport for notifications. But if we imagine, let's take this do this mental exercise. So we imagine that we use two-way active measurement protocol to measure performance metrics like delay and packet loss. So the notification here, as I understand it, intended from the remote BFD peer to the head end of BFD session. And that will be only to characterize what's measurements going between these two nodes. But if we use two-way active measurement protocol, then this head end will know whether the metric, whether the threshold being crossed, because just by the nature of two-way active measurement protocol. So then seems that that is not really much of the benefit. Yes, I agree that if somebody is using one-way protocol measurement method, perhaps like on-path telemetry in situ OEM or alternate marking method, then yes, there is some benefit. But the thing is that in environments such as DETNET, where we expect that service degradation will come before loss of path continuity, then BFD messages will be more relaxed compared to their measurements of performance. Because yes, we want to, because service degradation will probably be constituted before we will lose 3 control packets in a row. Okay.
Okay.
So because of that, it seems that it might be more useful to look at more generic case. And what I want to point out is the work that being done in IPPM working group for multi-SLO environments. So basically, when we have SLA, because if we look at DETNET, we have several performance metrics that really define what we in this work call precision availability metrics. So violating or crossing thresholds limit for each of the metric makes this service, DETNET service, unavailable. So it fails to conform to the requirements. So in this work that now being cleared for publication, we use network slices as an example. But I agree that DETNET would be another useful example. And I think that this paradigm of multi-SLO environment and precision availability metrics is very much applicable. Also, I can point to the work on extending PAM in IPFix. But it's not only that can be used. It could be basically signaled or notified through based on a Yang data model for precision availability metrics. So I think that it's okay. There is a need to do notifications.
Yes.
I think that BFD is not the right mechanism.
Yeah.
And there is a need, probably if you look at more generic mechanism, it will benefit not only DETNET application, but as other applications that share the same multi-SLO environment. Thank you.
Okay, thank you for your comments, and we will seek for more generic methods. Thank you.
Okay. And this is your next presentation too? Is that right? Or did I mess up?
Yeah, okay, this is also messed out. This work is echo request and reply for DETNET community discovery. Next slide. Okay, as described in RC 8655, DETNET provides a capability to deliver packet data follow with extremely low packet loss rates and bounded latency. And in RC 9551, it requires DETNET OM to support the discovery of DETNET relay nodes and the discovery of public packet replication elimination and order preservation function locations. And it also requires the collection of DETNET service sublayer specific informations. And the DETNET service sublayer OM introduced a DETNET pin method to used to collect the service sublayer specific information, including the configuration and accelerators. And this draft intended the DETNET pin to discover the enabled DETNET capabilities. Next slide. Yeah, we introduced a DETNET capability discovery object to deliver DETNET capabilities of relay nodes. So the object is consists of abstract object header and capability metadata. The abstract object header is the format is depending on the forwarding plan, and the metadata includes the detailed capability, the request or replied in the echo request and the reply package. Next slide. And the first object is a DETNET capability object. This object can be used in echo request or echo reply message, and when it appears in an echo request packet, it indicates the DETNET capabilities, the DETNET pin indicator request, And when it appears in a DETNET reply packet, it indicates the capabilities that the relay nodes enabled or supported. We define 4 flags for this object to indicate the detailed capability of DETNET capabilities. Okay, next slide. And also when the relay node to generate that echo reply packet, it need to encapsulate its ON node ID. So we define 3 types of node ID for different forwarding plan, and also 4 types of operation codes for the service operation on a node. Next slide. And we also define a service protection function objects to indicate the supported service protection function. Yes, we have it includes a SL flag to indicate the sequence number length, and also the OP flag to indicate the detail protection functions. Next slide. And for the flow configuration, we define a service flow information to deliver flow configuration information. So it consists of several flags and a flow label. The flags is used to distinguish the incoming or outgoing flows, and the flow label is used to identify specific flows. Next slides. And yes, we have a service flow information object for IPv4, and the only difference is that the flow identifier for the IPv4. It is a 6 turbo to distinguish each flow, and has a optional IPsec parameters index. Next slide. And yes, this is a flow information object for IPv6, and the only difference between this and IPv4 is that it has a IPv6 flow label. This is also optional. Next slide. And yeah, for next steps, we are going to continue collecting comments and suggestions from groups and to improve the drafts. Next slide. Okay, thank you. That's all.
Greg? Greg, are you still in the queue?
I apologize, I didn't lower my hand.
Okay.
But thanks for this, because I was intended to comment. Yes, I think that there are many different ways, but what I wanted to point out that you might look at not using ICMP, but for ICMPv6 specifically, for the extension of discovery of the functionality, but similar to what's being done for in situ OEM capability discovery. I believe it's no discovery. I'll send the reference to the list, to the chat room, and to the list about it. But again, there are not one way to slice the bread. So I agree. If somebody wants to use this,
sure,
that can be done. But again, because we already went with through the discussion with the 6-man working group, and they suggested to use a different mechanism, different from ICMPv6.
Okay.
Thank you.
Okay, Lou?
Yes, and I will lower my hand.
Thanks. Lou?
Hi. Who is the consumer of the information? I think the speaker should come back.
Could you come back? Yeah, got a couple more questions.
So sorry, could you repeat your question?
Sure. who's the consumer of the information, of the notifications that you're passing?
It is the let me think. It's the DETNET pin indicator. She is the consumer. It is consumer.
I'm sorry, who?
The DETNET pin indicator is it is a draft, existing draft in DETNET, I think.
I'm not sure I followed, but if I understand this correctly, you're just it's capabilities advertisement. Is that correct? This is just capabilities advertisement.
Yes, it's a capacity advertisement. Sure.
So generally, if you're talking about a in-network control plane using it, we've generally done that in routing rather than OAM. And if it's a out-of-network controller, generally we've done that in Yang. So I think it would be good to, in the next version of your document, highlight who the consumer is and make sure that it makes sense to use that approach. Thank you.
Okay.
The word how
Where
you do
to
it in the
die?
network got clobbered up on audio here. If you do it in the network, this is done with, right? The word was missing. Can you repeat that sentence? It's gone now.
I'll write it in, but if I was just saying, if it's done in the network, generally we use routing to advertise capabilities in the network.
Okay, thank you.
Hello. This presentation
We have
is
one more person in queue, and I think we have time for it. Sorry. Maybe a little quick changing the slide deck.
Hi, Mark Smith. I might have misunderstood, but it seemed that the flow label field was intended to carry this information. No way. It's not flow label information at all. So we've had a lot of debates about that, but flow labels for flow labels, and that's it.
Yes, maybe we can discuss offline. Yeah, okay, sure. Any more questions?
Okay. Thank you.
By the way, Torlis, you were the last speaker today, so you have a little bit of time.
Okay. Well, hopefully feedback. I don't want to really say so much, although it is obviously a complex topic. And so we've been starting a different set of options we're proposing for this hop-by-hop large scale QS for bounded latency. And many of those mechanisms would require additional metadata in the packets to be working. And so far we have pushed forward just how we would actually do that in IPv6 or MPLS, whatever the forwarding plane is. And I feel it would make a lot of sense to start talking with the appropriate working groups in parallel. My folks are mostly interested in IPv6, which is why this is for IPv6. But obviously, if we feel this is a good strategy, we should also go to MPLS. But hopefully somebody else will start taking the lead on the MPLS side for that. But same issue, I'd say. And the reason is that I think, first of all, we'll have a very hard time, and I don't think we even should try to elect just the one single winner and then sequentially afterwards try to figure out how to put in the packet header. But I think there is really, the need for a lot more experimentation and having packet headers that are allowing to very easily support a different QS mechanism with the minimum amount of additional per QS mechanism IETF work. So I'm trying to split the work, how to get QS for DETNET and for other purposes into IPv6 extension header into two pieces, right? One is the common framework, which we would be doing in 6-man, and then the per mechanism work that would describe the semantics of the individual metadata in the header, which would then happen hopefully in DETNET or in the CCWG, or even for research stuff in ICCRG, right? Or even outside, right? So that we're not even constrained to only standards tracks mechanisms being able to use an extension header, but that we have the ability with the least amount of churn to IPv6 to support multiple different mechanisms. Next slide. Right. So this was a little bit the perspective from for the six-man working group, which really is how do we minimize when we want to start doing experimentation, people starting to deploy different mechanisms, that we're not running out of code points, and also a lot of open questions about, you know, do we use IPv6 extension header options, or do we use a single new header? When and how do we do the hop-by-hop header versus the destination option header? So I have a couple of questions, but I think I have a pretty good capture of the overall things how we should do. But this draft is not the proposal itself, but it's a discussion. And one of the big thing I think the discussion should do is, for all the different mechanisms we think could happen, that we have a quick summary of each of them, right? So the authors here are from the folks that I work with, where we're reviewing our drafts. But for any of the other mechanisms, please come to us so that we can add a short section on each of these mechanisms, so that the folks in six-man and maybe at some point in time MPLS or so have an idea about what metadata does what stuff for QoS, if they will give us extension header space for it, right? So that's a purpose of the document. Next slide. So this is our own DETNET stuff that I was mentioning. Next slide. Right. So, oh no, wait a second. Let me stay on the DETNET stuff. So I think one of the things, and I think we're having another presentation in the second DETNET meeting, I think there is really a shift in how much QoS we can develop more quickly coming to even high-speed hardware, and that's because of programmable QoS, which we didn't really have well. So the PIFO stuff, the queues where you can push in, that's being shown now with the latest research papers from CMU and last year from Huawei and other universities. So I think the programmable QoS is going to give us a lot more options in a few years, and I think so we're right in time to start working on these algorithms now. And then of course also the ability to have more flexible headers without going back every time to the IETF necessarily would also even allow to use the same header for proprietary ones, right? So we'll have a new registry code point in the header that then allows to even have some values for proprietary versions and or standardized experimental informational from the IETF. And I would hope I can also try to find some people on the congestion control side, not only DETNET. I think a lot of cool stuff could be done there, but I think currently the research on that side is far behind in the IETF. Next slide. Right, so if we're using a separate extension header, it would be just next header. Header extension len is the standard IPv6 format, and then we would have an 8-bit method. That's the registry space from which we allocate. Then we subdivide that space, for example, into IETF standards, experimental, and maybe even configurable, and of course the usual different schemes on what degree, how much do you need to prove, you know, standard, there's expert review and all these things. So those are things that would have to be worked out to be able then start allocating methods into this space. And then of course the question, do we allocate that once for hop-by-hop header, and I think also once for destination option header. So this is kind of the starting point of the discussion. Next slide. Yeah, so I don't want to bother you with all the details. That's why the draft is for. Let me get to the beefy slide, you know, kind of. Next slide. Yeah, so everybody loves ASCII art. We're trying to get rid of that, but still. So sorry, it's way too small, right? So what I've been thinking is that we definitely need one IPv6 destination option header to do the pre-auth. Right, the sequence number that we already have in MPLS, we haven't gotten that in IPv6, and I also think that an end-to-end timestamp for playout buffering, which we talked about when we convert from an in-time mechanism to an on-time mechanism to a synchronous latency. So that would be, for example, one particular type of metadata for the 64 bits, one method for DETNET destination option header. Do we potentially in the future need multiple? I haven't seen us coming up with reasons or needs for that. So maybe one is good enough there that we can standardize. But then when it goes to the hop-by-hop ones, here are the 4 mechanisms. And it's already, you know, when I was talking around with the authors, really writing down what the metadata are, what resolution it should have. Okay, it should be microseconds, and then 32 bits are enough. We need overview. So I mean, even having such header discussion brings us closer to 1 degree of discussing details that algorithmically have been so far, I would say, been left behind because they're just too practical for the algorithm, but they're needed once we get closer to the wire. So yeah, so the C-score, that's really the cool thing in time. So it has service rate and then finish time. So we need, what is it, 48 bits. The TCQF, that was really designed to have very little bits, right? So we're still trying to stuff it, if necessarily, into the 3 bits or 8 bits DSCP or MPLS. But of course, we've already seen people not liking that backstabbing into existing methods. So we'd be thinking we're fine with, what have I done there? Something like 10 bits or so of a cycle, 4 bits, 3 or 4 bits priority. That is similar to how TSN has been doing these things. And yeah, so we don't even need that much of a space. So one of the ideas was have a fixed space length, even if you don't need everything for all the methods, because of the simplicity it gives to the parser. So we've seen every time we have a variable length field, it potentially increases cost of parsers. So rather spend another 32 bits nobody needs in this packet. And so that's one of the cool, important things. Would also collect a lot of mechanisms to really see, do we get away with 64 bits? Does it need to be 96 bits? I would say as long as we're shorter than a full IPv6 address, we can, I think, still value these things because SRH is there and kind of, relatively speaking. But 8 bits is not good enough for QS anymore, is I think what the story should be when we go to 6 men, right? And this is it. So yeah, so then the TQF method, that has an interesting thing. So first of all, terminology different. It's time slot instead of cycle. It's also longer, and there is an interesting functional difference with the deviation in terms of when packets. Please mute yourself. Somebody remotely next to create a feedback loop. Okay. All right. So, yep, that's that. And then the last one we had. Excellent. Gets
QoS test.
perfectly. Get ops points. Yeah, and then the last one was this GLBF damper method. I think we're also going to see another damper method on Thursday. So yeah, so that's a hop by hop updated damper time. So this would be an example with explanations, and that is then for 6 men for MPLS, that they do see that all this exists, maybe at different degrees of validation in high-speed hardware or simulations or just in software, but as far as real beef and what can be achieved with it, that they do get an overview. Next slide. Right, and I wanted to say that DETNET isn't the only one, right? So in the past, I think there was a lot of really cool research for congestion controlled mechanism, right? So one of the first one was from one of the famous professors, Stoica, DPS, that was in the DivServ working group, I think, in the year 2000, and they also just gave up on the, okay, how do we get our metadata into packet headers? And that was kind of so early in IPv6, I think the answers must have been just go away, right? So, but that's, I think, also very much the basis for what C-score then builds on top of. So, so I think there are a lot of really cool things for congestion control that could be done. I was involved something like 10 years ago, a little bit in research with more than 8 ECN bits to do faster things, upspeeding parameters, right? So when the congestion control folks know that they could have 64-bit of metadata, maybe there would be more interest to also work on the congestion controlled QS improvements in AQM and other mechanisms. Next slide. Yeah. Yeah, so we had 2 feedbacks from 6 men, so this goes outside of the scope of DETNET, so I think I'll talk about this in DETNET on the feedback. So yeah, please, if you have other algorithm, please come to us so we can put in the discussion. The goal would be to see if we hopefully can have a real draft with a proposal for Vancouver. So please, support the effort if you think this would help us to go forward. This will not have any impact on us how to decide what we like to standardize or so in DETNET, but I think it should open the opportunity to have more of the documents be adopted at different degrees, right? So if they haven't seen that much validation, maybe they're experimental, or if only the algorithm without any validation has been done, it can be informational, right? So when we have a space of different degrees of algorithms, then I think it makes it easier to not just have a binary decision, yes or no, but doing appropriate classification of the algorithm. Thank you.
Okay, we've got some questions. Antoine.
Hello, Antoine, Huawei. So I have a question regarding, it popped up when I saw your header about advertising the finish time for packets. Does it make sense to have this information into the packet at the cost of overhead, or to advertise this information in a control channel with using information like the flow ID to carry the information about the expected arrival time or finish time for flows?
Yeah, so so you're talking about the destination option header where I put it as a proposal beside the sequence number. Is that what you're talking about?
Yes, when you showed this destination option, there was, I think, the second or third option where you had the finish time for the flow in the packet.
No. I mean, on the slide with the hop-by-hop options in something like GLBF or damper, this is calculated on every hop based on the leftover time after the queuing on the node. So that can only be done in the hop-by-hop option for damper algorithms.
Okay, so yeah, so sorry.
The other one was end-to-end, and that certainly is an interesting question. So the point of a lot of the stateless stuff is to minimize the amount of control plane operation that we need to have, and the minimum that we understand is that we need to, on ingress into the network, do some policing against flows anyhow, so that we won't receive crap that is overloading our network. At that point in time, also insert something like a routing header for the steering of the traffic on a reserved path. And then, for example, this QS header. And so we eliminate the need to do another putting in of state for each flow on the egress node. So that's basically this timestamp on the playout that we can insert on ingress.
Okay, yeah, I agree with the up-by-up remark on having the time into the packet. Regarding the end-to-end, I think it comes down to the discussion we had when I presented a draft in the interim a few months ago. I was mentioning using RSVP to announce QS contracts end-to-end, and I think this you raised the question whether it was RSVP was suitable for doing this or carrying the contract in the packet itself.
Yeah, I mean, this is obviously the attempt to completely eliminate as much as possible control plane that we have, and that we would only have, an admission controller and a PCE controller signaling to the first hop router in the network. That's the way on how we achieved scale so far with segment routing architectures in MPLS and IPv6. Right. Yeah. Okay. I mean, obviously, there are always critical points beyond that. But if I've seen a lot of, the explicit traffic steering tunnels with RSVPTE, where we then had all other much worse problems, right? So just compared to the alternatives, it's like democracy. It's the worst possible. So segment routing is the worst possible solution, except for all the others. Right. So, sorry. Great.
Okay, thank you. Greg Mirsky Erickson. Okay, so notes and questions. What's the use, what do you see use of sequence number in a DETNET forwarding sublayer?
So I wish that Pascal was here. So for the simple high scale kind of service provider segment routing type of thing, I think we wouldn't have this as and we haven't defined it as the DETNET forwarding sublayer function. So it's only part of the DETNET service function, right? And the large scale networks, I see that function be on ingress PE and egress PE. That's why I put it in a DETNET, in a IPv6 destination option extension header, so that it would only be processed on the destination.
But this information would not be used in IPv6 data plane. It will be used only by the pre-op function.
Yes.
Which is which does not belong in IPv6. It
Oh,
belongs, it belongs in a DETNET, right?
Well, but so, right, so this is now the interesting question. What functional difference do we get out of declaring such a header, an IPv6 transport header, as opposed to an IPv6 extension header?
Because if we define something for IPv6, it has a general applicability to IPv6 networks.
Yeah, and
so who needs it? In IPv6, who needs a
oh, I
number?
mean, the kind of, when I was talking to people who've been doing, highly resilient multicast, which is exactly the, dual path live transmission with duplicate elimination based on sequence numbers, they all love to have that in the network.
Yeah,
right?
they can have it if they need it. They can put it in their application, right?
No, I mean, if you want to do the merge in a network device, you would prefer not to have to figure out another signaling and putting this stuff into, for example, a new UDP header or so.
Yeah, because again, see,
I mean, why do we have
okay, next thing. Yeah. Because we don't have time to arrive to the mutual conclusion and agreement today.
But we have it in MPLS, right? So that's we do have the sequence number in MPLS.
We have in we have in DETNET control word. It's different. Excuse me. It's not MPLS label stack. It's DETNET control word. Okay. Please don't misrepresent. Next thing is you suggest that timestamp will be microsecond. It seems to be too crude. So I would encourage considering using a nanosecond as a unit. Second of all is when you say that you compensate for light control plane in a data plane, so we need to understand that overloads data plane DETNET resources with additional information that otherwise can be, because it's static. You don't change your packets and their information every other packet, right? So provisioning something for DETNET saves you precious resources in your data plane. So I would say that at least for deterministic networking, where we care about latency and packet loss, overloading data packets with information that otherwise can be provisioned, it's not a good proposition.
So that's the whole point, right? The scalability that we're trying to do is for when you run out of space to provision every individual DETNET flow in a large network, right? In the same way, can I finish? Sorry. In the same way as we would be saying, we would rather like to have segment routing to do source routing and reroute it as opposed to hop by hop fixing up the path. Yes, I do know that the standard DETNET architecture today effectively says every individual DETNET flow or aggregate thereof, you steer up hop by hop, but the whole scaling of the QoS discussion was based on eliminating that need for the per hop QoS operation. That was the whole purpose.
Yeah, well, the thing is that, again, I don't see how control plane will strain DETNET data plane out of resources, because effectively the control and management plane for DETNET flows, it's out of band. It's out of band from the point of QoS, and it can be physically out of band.
But I don't see the point.
Maybe take this one offline or the list onwards. There are two people in the queue, and we have 2 minutes. I would like to, Tolas, please stay. Tolas, please stay at the mic, because I have 2 comments and I see Kuan as well. First comment is that honestly, I do not really like approaching other working groups until the DETNET working group has made some decision. So the skewing discussions are ongoing, we are progressing, but there is no selection, there is no working group document. Everything is individual contributions so far.
That's fine. We can tell that the other working group, but the whole point is that serializing something where what would happen after, we're finishing something and only then we go to another working group and then we're stumbling and we'll have to, undo what we've done before. That serialization can also put, our work at serious risk.
I don't see it's under work, but at least we should have a rough view. And the other thing is, a second one coming to my mind is this proposal is kind of like writing a blank check on the headers, and then everybody does whatsoever.
No.
So
The
it's
whole
like
point,
that's not the point. That is looks like to me.
Right. No, that's not true, right? So one of the core question to SIGFAN, of course, is what can we, put in as requirements for any, allocation within that header to allow such an allocation scheme and approval of the mechanisms be done by other parties than SIGFAN itself, right? So I mean, we have a lot of registries where basically you have very strict admission rules, what you need to do so to meet that, and we have expert review, we have working group review, we have standardization experiments. So I mean, we have all these schemes in the IETF. The question is just, is SIGFAN willing and able to express if or how that can be made applicable to, a registration-based extension header?
Yes, we reached the top of the hour. I wanted to let Kuan make the point, but
look, I mean, we've been here for several years, right? So,
I think Kuan needs to take it to the list. Unfortunately, we're out of time. I think the last few minutes really highlights that we don't have agreement on the approach. Torlis, I think you said something interesting right there at the end about getting information on what is viable and what is not from SIGFAN would be useful. I don't think giving specific proposals is necessarily the best way to do it. So if you want to get that information from SIGFAN, I would suggest asking it in a general form, and that would be good information to bring back to the working group. And
sure,
allow us to have that as separate input from all this I think pretty strong disagreement on what you're proposing, the specifics.
Yeah,
so I think maybe you've gone a little bit ahead, but we, and with that, we are definitely over. And thank you all for a really good session. Thank you all to the note takers and those who participated. Eve took fabulous notes. Thank you. And also thank you to the in-room delegates.
Thank you, everyone. Talk to you on Thursday on our second session.
Thank you.
Thank you. Bye.